So I think it's time now, so let's get started. So hello everyone, I'm Wenchen from Databricks, and this is my colleague Xiao. So today we are very happy to be here to share the latest updates of the ongoing Spark 4.0 release. Okay, let's go. Same as usual, so every release of Spark will come with a lot of improvements, new features, and bug fixes, and make Spark a better tool for data analysis. So in this talk, we will cover many features that we GA in this release, will be GA in this release, and improvement for different areas, including SQL, Python, streaming, and some features that can make it Spark easier to use. Okay, so today we will cover two sections. So first is we will introduce some new features and functionalities in Spark, and then we will mention something for Spark extensions, and then some custom functions and procedures, and also about the usability of Spark, which is also a kind of pain point of Spark, used to be. Okay, let's start. The first thing, I think probably the most important thing in Spark 4 is Spark Connect GA. So for people who don't know Spark Connect yet, so this is a quick recap. So Spark Java is very heavy today because we have many things in the Java like SQL engine, streaming engine, machine learning libraries. So it's quite a heavy JVM process. So this makes it hard to deploy your application because it must be live with Spark Java. So it's time to make Spark Java a service so you can make your client very lightweighted. So that's the idea of Spark Connect. So we use JavaBT as a protocol, and we send the logic plan to the server, the Spark Java, to execute the query, and all with a very thin client. So you can put a client in any application you want, in IDEs, in any language you want, because it's just an open standard. So let's make it easy to use Spark in any place. So in Spark 4.0, we are GA the Spark Connect feature. So now you can interactively develop your and debug your application with IDEs, and we also support many languages like Go, Rust, and Scala 3, and which was also coming. And also you can build the application everywhere. So this is all done with Spark 4.0, Spark Connect GA. And one more thing with Spark 4.0 is that we really have a very thin client in the Spark with Spark Connect. So now you can just type install PySpark -connect, and it's a very small library that it's pure Python, no JVM, that's carried by Spark Java, and it's pure client, no server-side stuff. And as a result, it's only 1.5 megabytes. Well, before, if you just pub install the PySpark package, it's more than 300 megabytes. So it's preferred if you can migrate your application into Spark Connect entirely, and it will make the life easier for you to deploy your applications. Okay, next big announcement is ANSI mode. So Spark has introduced ANSI mode, I think, many years ago. The goal of ANSI mode is to improve the data quality, to turn the long data into long-time arrow instead of silent nonce. So in case you don't know the ANSI mode, here we also have a complete document to explain all the different behaviors for ANSI mode. So you can follow this document to turn on ANSI mode and fix your query and find your dirty data to make your data quality better. So these are some examples. So for example, let's see a very common example is like divided by 0 in your query. So before ANSI mode, you just get none data, right? Divided by 0 and it's none in your result, which may affect the downstream pipelines that can give you the wrong insight. So with ANSI mode, we will just give you a very clear long-time arrow, say, hey, this is a division by 0. And we also carry with arrow context, tell you which line of your SQL is caused this division by 0. And but in 3.5, the latest Spark release, the message is very unclear because there's a very weird arrow wrapper in the beginning, says, hey, the job is aborted, blah, blah, blah. And I mean, most people don't understand, it's very Spark internals. So in Spark 4, we improved the arrow message even more. So now we remove the wrapper and we integrate the arrow context with a playable application, for example, in Databricks notebook. So the notebook will highlight the section of the SQL that caused this dividing by 0 issue. This can help you to easily debug ANSI errors in your application. And also the same for different queries. The previous I showed the SQL query, right? Same for def range. For def range, we also carry the arrow context, show you which line of your Scala code contains the place that creates the division operator, and also which is the operator name. This time is div operator. So there are many things ongoing, and we hope to complete all of them in the Spark 4.0 release. So for example, the PySpark support, you can point to the Python code file as the file and the line number, and also Spark Connect support. Even if you run your query on Spark Connect client, we can also carry the arrow context and show you which place of the of the query contains the arrow operator. And also we will also support this feature with our native notebook so that we can highlight the arrow code in the notebook. Okay, and another very good new feature for Spark 4.0 is the variant data type. It's a very good tool for dealing with semi-structured data. So let's get into it. So sometimes data is just dynamic. You don't have a fixed schema of it. So previously, before this feature, so most people choose string type column. They just store a general string in the string type column with, different field names, different types, and then they just use the Spark functions to get the string field or value at the runtime. And then Spark will give you runtime error if the type is matched or the field doesn't exist, whatever. But JSON is very, very, very slow. You must pass the entire JSON string to get the field you want. And in Spark 4.0, we add a new variant data type for this exactly same use case. So it has the same flexibility as JSON, and also it's open standard. We published the entire binary format spec in the Spark repo, and you can also follow the spec to have your own writer for this variant value, and also it's very fast. So in our benchmark, so this example of the variant type. So first, let's say you just get a variant value from a JSON string. This can also be done with some custom writers if you follow the variant value binary spec. So once you have the variant value and set in the table, so when you scan it, we provide a very neat syntax, the semicolon, to extract a field from it. So if the field doesn't exist, it will return none. And what else is the ILEC function, that every function in Spark has implicit cast. So in this place, the content that we want to have run the ILEC function, which needs a string type. However, the variant extract field returns a variant type again. So the Spark will implicit cast the variant value to the string type and give you runtime error if it's not a string. Like for example, it's an array or a string or map, a type that cannot cast a string. So this can all be done automatically by Spark. So just need to write your own query with variant value, and Spark will just do the cast for you. So for performance, we did something in Databricks. So compared to JSON string, so you just field and do cast. The variant type can be 8 times faster than JSON because it's binary format. You can just navigate to the of state of data you want to read. So while JSON, you must pass the entire string to get the field you want. Okay, next one is string collation. So this may not be a very common feature you may see, but if you want to start with dealing with some details of the human language in different countries, this feature will be very useful. So for example, case sensitivity and accent, locality. So these all can be controlled by this new string collation feature, and it's supported in all the functions in Spark now. String functions like lower, upper, substring, locale, and group by, order by, join keys, and also in Databricks we support this with delta lake and phantom. So let's give some examples. So let's say you want to order some string values in your table, and by default, it's just some ASCII code. So the uppercase letters are always smaller than the lowercase letters, and then some spatial variant, which about accent is just called microns. So this is what you get up. So it's kind of not very intuitive, right? So why the uppercase A is smaller than the lowercase b, right? Uppercase b is lower than the lowercase a, so just that makes sense. So with string collation, now you can say, hey, so I want to do this with collation Unicode. It's kind of the root collation for string values, and it works well for most cases. So here's an example. So the definition in the Unicode collation is that any letter A is smaller than the letter B. Whatever variant, like whatever macrons, lowercase uppercase, they are all smaller than B. So this makes more sense for most people. So now let's do something more fancy. So now let's say we want to use the start with function to fill out some string values, and I want to be case insensitive. So now I use the collation Unicode underscore CI, which means case sensitive, and I want to start with the letter A. So you can see, hey, now I want to get the lowercase and uppercase A. So here we found that there's one name missing, which is the A with macrons, right? You see before. So why is that? Because that A is not about case sensitivity, it's about accent. So we have another collation, Unicode_C_AI, which AI means accent insensitive. So now you say, hey, I want to start with the letter A, so it will just feed out all the string values that start with the letter A with different variants. So there are a lot more collation we support in Spark. On the whole, we use the SQL library to support hundreds of collations for different countries and languages and the different flavors. So you can try it out and fine-tune your string behavior. Okay, another one is streaming state datasource. It's about the streaming engine. So just for a quick introduction about the streaming processing. So in case you haven't entered this area before, so for streaming processing, you must have the ability to do the recovery, right? But streaming query lasts forever, so you must be able to be stopped and restart the stream query from a point. So there is a concept about state. So the operator in your streaming query may have state, and they must be stored in a state storm. So this state is usually a key to investigate, to debug your streaming queries, because it contains all the internal information of your streaming query. So in Spark 4.0, we will introduce a new data source called streaming state data source. It allows you to inspect the interval state of the streaming application for debugging, for profiling, for testing, for troubleshooting, for whatever reason you want. And it's a data source that can also support the write. So it allows you to manipulate the internal state of the streaming application if you want to recover some very urgent streaming issues and to make your query still running. And all of this is done with your familiar streaming, data API. So let's see an example. So we provide provide two reader data sources for streaming state. So one is a high-level one called state dash metadata. So in this data source, you see that we can just use the familiar API, Spark reader format, and format name and load. So it will print the very high-level information like the operator ID, the name, and the state storm name for you to debug your state storm. And also we provide a low-level API data source called state storm. So this one provides the low value of your state storm, which is actually a key value format. So if you know streaming very well, you can look into this key value, low values, and investigate your streaming application issues. Okay, another one about the streaming state is some new API will allow people to customize the streaming state management. So so why we have a V2 version? So first we already have the V1 version to allow you to do some custom operation on your streaming state. We use API file map loops with state. So the problem with this API is that it gives you a single user-defined state object for you to define how you want to define your state and save it. And every time you want to make an update of your state, it just updates the object, and the Spark will fully refresh this state with the new object. So this is not very inconvenient. So first, it's not very good for performance because you want always a full update. If you only want to update one field of it, you just update the full entire object. And also, this single object model is not good for data modeling. Let's say you want to have multiple similar streaming applications. They want to share some common data models, but this V1 API isn't good for that. And also, there are some advanced features we don't support with the V1 API. So, for example, eviction, right? The state cannot grow forever. You must have some policy to eviction the state to make it have a reasonable size. And also, schema evaluation. So, same as your data. So, your state can also evolve with new logic. Yeah. So, so these are all the limitations of the current API. So, in Spark 4.0, we have a new V2 API. It's redesigned API for this customer state management. It's layered, more flexible, and more extensible. So there's also a session in this summit to go into details of this feature, and you can also follow that. And pandas 2 support. So in Spark, we merged the previous Collation project into Spark as a pandas API Spark modular. So it allows you to use a very simple change on your import code to run your pandas code with Spark clusters. So in Spark 4.0, we support the pandas 2.x API. So before it's pandas 1, so it's backable interoperability. So you must be careful when you upgrade to Spark 4.0. So we provide a very detailed adaptation guide to expand the differences in the pandas 2 API. Okay, next about extensions. Okay, so first is the pandas data source. So you may also see that in the Spark summit last year, also data summit last year. So in Spark 4.0, we support both stream and batch for the pandas data source. So it's fully GA now. So the motivation. So while we have the pandas, we already have datasource API in Java and Scala, right? Why do you have a Python one? It's because Python is kind of the #1 language our customer want to use. They don't want to write Java or Scala, they just want to run pure Python. So, and also if you have a Python datasource, it's very easy to install it, with just a very simple pip install command. And also we simplified this API in the Python datasource to remove some complicated performance features that exist in datasource V2, which make it very super hard to use. So here's progress. So we have the SQL IP for the pandas last year, and it's available in the Spark 4.0 preview release already. And also it supports both batch and streaming, read and write. So just an overview of how you can use the pandas. So it's just very simple, three steps. So first, you define your datasource class, extends the Python API, and you can do whatever you want in this implementation, like REST API, like read database, read files. And next, you just regest this datasource with the new PySpark API, like spark.datasource.regest. And finally, just as the same as the normal datasource, use the familiar Scala API, different API, spark.read format, and to load and save this datasource. Next is a two convenient function we added to the PySpark. So one is the Arrow. So Arrow is very popular now. It becomes kind of a default format, inline format for current data. So we added a new API in PySpark different. Arrow makes it very easy to convert a PySpark different to a PyArrow different, and then you can just feed it to other PyArrow existing libraries. However, one note that this PyArrow table is in your Java, so it takes a lot of memory if the table is big. So we also add a new function called apply in Arrow. So this one is that we created this PyArrow table in the worker side, and you can then invoke other Python functions to consume this PyArrow table. So this is more scalable. Okay, we also have some very convenient new connectors. So one is XML connectors. So XML is still being used by some guys, some customers. So now Spark supports it out of box. So just call Spark read the XML, give it the path, and now we can just read the XML file for you. You don't need to search in the internet and find a third-party library to read XML files. And it's not just more than just a simple port. So we also add many improvements. So we merge the third-party XML library into Spark, and we add more improvements to it. We fix bugs, we improve performance, we add new support for like new types. And now it's same as the other file source in Spark. It supports bucketing, partitioning, and all other features we have in file source. Another one is Databricks distributed dialect. So if you are a customer of Databricks SQL, so before that you cannot do this out of box. There will be some syntax error, and now it just works out of box. So just type the JDBC URL of the Databricks SQL and just load it, and it will show the table for you because we added the dialect support in Spark. Next one is the Dialect 4.0. There will also be a station in this summit to introduce a new idea. I just give a quick preview. So the Dialect 4.0 is kind of basically released in the Dialect history. So it contains many new features, as I mentioned before, the variant and the uniform, which you also see in the keynotes. So I'll just give you some pre-updates. So uniform allows you to just don't worry about the comments anymore, right? You just whatever you want, Delta Lake or Iceberg, and the uniform will just copy all this metadata for different formats, but reuse the same data files. So and then it will make you life easier for choosing the formats. And the other feature we GA in Data 4.0 is Liquid. So Liquid is a very convenient way to optimize the data layout. Just to define the keys that you want placed against it. So you don't need to worry about the file size and like the NDV of your column values. You just say, hey, this column I want to put it against it. So let's just put it as a cluster key. And even that can be removed by the AI, as you mentioned in the some keynotes. So we'll use AI to analyze which key is the mostly being filtered on, and we'll just set it as a casting key. And then with the GA, so we can show some numbers of the casting key feature. So it's very easy to use, as I said, and it's like provide up to 7 times faster than in the rise than just vanilla high partitioning feature, and also like up to 12 times faster on reads because on the whole, it uses ordering, which means it's multi-dimensional ordering. It doesn't matter how you order your keys, and it's very flexible. Okay, next I will hand over to my colleague Xiao. Okay, thank you.
Yeah, thank you, Wenchen. So next I will present the next 2 topics, and then I will go over the PySpark updates. So Spark 4.0 introduced significant enhancement including the extended customer function capability, like SQL UDF, SQL UDTF, SQL scripting, store procedure, Python UDF, Python UDTF, Arrow optimized UDF. I will go over one by one. So we added Python user-defined table function in 3.5, so you already can use it. So this function are very powerful, so allow you to return a table, a set of rows, instead of just a single scalar value. So this feature is particularly useful for complex data transformation. So UDTF can be integrated into your data workflows. As long as you register this function, you can call it from, just like a built-in function, you can call it from SQL. You can call them from data from API. So Spark 4.0 enhanced UDTF by adding 4 more features, like polymorphic analysis. You can just generate a dynamic schema based on the input arguments. And also you can specify input table partitioning, then it can improve the performance and the resource usage. Variable keywords arguments allow you to be more dynamic by accepting any number of keywords arguments of your UDTF. And also custom initialization. This will configure UDTF once per query. So in 3.5, we added a Arrow optimized Python UDF, but by default, this is off. So now, starting from Spark 4.0, Arrow will be default. Enhance the Python UDF performance by speeding up the data serialization and also ensuring the consistent type handling. So there's 2 ways to enable these features. You can activate this locally by using this use arrow, or you can set the Spark config. So this is a session level config. This charts compare the traditional Python UDF and the Arrow optimized UDF. This just show how amazing Arrow is to reduce overhead and speed up the operations as data volume increase. The performance improvement is more significant if your Python UDF are chained. This is just an example. But this is a pretty change. Like what I mentioned, it improved the data type handling, but it also changed the results. So if you enable it in 3.5, double check, make sure this will not affect your pipeline. SQL UDF. So SQL UDF, very simple, powerful extension to Spark SQL. And in Databricks, we added these features 2 years ago. So almost all the customers are using this. This is very powerful, performance is very good. So in 4.0, we add this to the Apache Spark. So SQL UDF and UDTF can extend our SQL function library in Spark. So with SQL UDF, we can encapsulate complex SQL expressions, making them usable across different queries. And the SQL UDTF allow for parameterized view. It can return multiple rows of data and enabling more dynamic data transformation workflows. So let us just explore the SQL user-defined function first. So these functions are designed to return a single scalar value. It can include complex expressions. So you don't need define your own UDF. So it just reuse existing built-in functions. It can include the subqueries. It's very popular, useful for calculations that are too specific or complex to be handled by the built-in SQL functions. Of course, the performance is better than typical Python UDTF or Python UDF. So this example just shows the particular application of SQL UDF. So you can see how a custom function, row dice, can be used to simulate dice rows within SQL by calling this like built-in SQL functions. Moving to the SQL UDTF, so which can handle more complex cases. This function can return a set of rows can be used directly from the from clause in a SQL queries, just like the table. So this example shows a SQL UDTF returns all weekdays in a specified data range, utilizing the set returning operation, and later joins for integration with other SQL clauses. Yeah. Finally, name parameter inversion in SQL UDF can enhance your code readability by allowing parameters to be specified by name and reducing the errors. Stop procedure. So Spark 4.0, so we introduce external stop procedure, so you can call it from Spark, for example, Iceberg. This is just an example. You can call stop procedure defining the external system, like Iceberg. Now we don't need a hack in the Iceberg side. You can directly call Iceberg building stop procedure, roll back to timestamp. And also, Spark 4.0 introduced a native SQL scripting, enhancing the SQL with control flows, like if, else, case, while loop, error handling. So this is very typical data warehouse features. This can help your migration to Spark to Databricks. So this example shows a stop procedure with a while loop for efficient batch processing within the database. Now you don't need to call the PySpark for this. And now here as a more complex SQL scripting, dynamically altering the database schema across multiple tables. So in Spark 4.0, we also introduced a unified profiling, this for performance, for memory analysis. So this feature offers both performance and memory profiling. It's designed to replace a legacy profiling method. It supports Spark Connect. This is session-based. It can check the detailed metrics like function calls, execution times, and memory usage. I will show examples later. To activate the unified profiling, you can configure it so the Spark setting, you can set the perf for performance and the memory for memory checking, and use the show to display, dump to save, and the clear to reset the data. So this example, we're using the pandas UDF to add 1 to each element in a range of numbers. It supports all the user-defined function, Python user-defined function. So here just an example of a pandas UDF. So by setting the profiler to perf, you can see how the function performs, identify the bottleneck, understand its execution time. And here, same UDF, but setting for like a memory profiling. So we can use a memory profiler to check the memory usage by function, so that we can optimize the results. Sometimes if hit out of memory due to your user-defined function, you can use it to identify the issues. Okay, usability. Spark 4.0 enhances the Spark logging by transitioning to the structured logging framework. So this will improve how we handle this, like analyze the log data. So our goal is to implement the structured logging in Spark. So which means it moves from the unstructured data logs to JSON formatted log. So we'll introduce a dedicated system log directory for log management. So analyzing Spark logs can be very tough because they are unstructured, making it very hard to quickly pull out the insight, especially when you need to analyze a log generated by different Spark versions. It's just a very, the log message format, everything could be very different. It's hard to query, to analyze. Now, starting from Spark 4.0, logs will be in JSON format by default. So this change makes it easier to parse, analyze logs. So I can show you some example how to use these structured logs. So with structured logs, you can use the Spark itself to analyze the logs data efficiently. So So here you can query logs directly within the Spark to get an insight immediately. So this is just an example. So we set up the system log directory to store these JSON logs. You can query, you can get all the errors on the host, especially the host. You can get all the exceptions from the Spark. You can get all the executor logs. You can get all the distributed logs for specific executors. Okay. Today, we will also show our latest progress in the Spark 4.0. So Wenchen just mentioned ANSI-related error improvement. This is just a summary. We move over 800 common error conditions to the new framework, still ongoing, covering everything from the parameters name to execution commands, making it easier for you to understand what happened in Spark. In PySpark, we migrated all the 200 error conditions, and our focus on the error quality clarifies and standardize error classes and improve the documentation, enhancing the debugging and the maintenance. So we changed the error message to clearly explain the problem, cause, solution, workaround. So this is just an example of PySpark errors. So previously we saw some Python exceptions. Now we saw the very specific exception from the PySpark. And also this is another example in the PySpark. You can see previously we exposed many internal details to the end user. Nobody understands. I mean, for most of the users, they don't understand jobs, they don't understand the stage. I mean, there are so many useless information in your error message. Now we just make it very clear. We show the error class, just a very clear error message. Yeah, it will be much easier in the future, especially for the runtime errors. Okay, I believe most of the people, users, already feel very pain about the behavior change. So migration is very painful. So starting from, Spark actually used the semantic versioning. Major means for API stability, feature for new capability, maintenance for patches. So in the community, we started a discussion to just classify the behavior changes. So in the future, we will make it transparent to discuss more in the dev list, to discuss all the behavior changes before we release these later changes. So this is just examples, the behavior changes we should highlight, we should avoid. Communication is the key here. The general approach is to avoid API changes and prefer the deprecating the features instead of changing the API directly. And also adding the legacy flag, we can use it as a workaround. We will improve the user-facing documentation, update the migration guides, add the legacy config, improve error message, and make it clear, provide a workaround. And also in the open source community, we will improve the PR description, provide more details, the reason, the context, and make it very transparent to all the peoples. This is pretty useful for most of the developers. Documentation. Spark 4 improve our documentation in many different ways. We introduced a dark mode. We added many examples. Also added the environment setup guideline, more quick starts. I also added a refined type system explanation for PySpark. And then we are also discussing in the community, in the future, we might introduce a versionless documentation. Yeah. So this is still ongoing. Okay, so let's talk about the PySpark updates. So Python is the #1 choice. Check out this graph. Over the years, Python has not only overtaken, but also stayed ahead of old language like Java or C++. So just to show how popular it is. So back in the 2013, PySpark was born, blending Python's easy of use with Spark's robust data processing capability. So this was a game changer for the Python developers, if they want, especially for big data processing. So the number of PySpark downloads speak for it themselves. So we're seeing like over 300 million downloads a year. PySpark popularity skyrocketing, proving this is the key tools for data science, data analysis, and the data engineering. And also, based on the PyPy downloads, PySpark is now everywhere. So it has been downloaded from 210 countries and regions in the last 12 months. And the PySpark provides a very powerful bridge between the big data and Python. They offer 3 different API, different API, SQL API, pandas API. It is optimized by our catalyst optimizer and adaptive execution. So it integrates with the Spark ecosystem, many different connectors, and also Python ecosystem. So the focus of PySpark in the last 2 releases is majorly functionality parity with the Scala, with the pandas API, and also easy of use. We added 180 functions. By the way, I will show it in the next slides. So, and also another focus is easy of use to make it easy for the Pythonic, for the Python users, add many Pythonic APIs, and also improve the performance, like what we just mentioned, Arrow optimize the Python UDF, and also try our best to integrate with the Python ecosystem. So this is a key enhancement in the 3.5 and 4.0. We added 180 new built-in functions in Spark 3.5, and also added a native datasource API, added Python state streaming processing V2 API, and the UDTF, and I'll make it easy to use, like the Spark Connect, Arrow framework, documentation, and also profiling tools. Performance, Arrow optimized UDF, varied data type, like more optimizer and execution improvements. And the ecosystem, pandas API is compatible, will be compatible with the pandas 2, and also added a distributed tuning with the touch distributors, and also Arrow integration, the 2 API Wenchen just mentioned. Okay, PySpark, so many amazing achievements in the last 2 releases, just amazing. To conclude, thank you for all the Spark contributor for driving this. So thank you everyone.